All right, guys, this is adding and subtracting rationals. And so just to review the rules about adding fractions, they have to have the same denominators. So notice both of these fractions, a over c plus b over c, we just combine the tops or the numerators and keep the same common denominator. And so that's how we're going to start. So notice in the first example that both of these have the same denominator. And so we're just going to bring that over and we can just combine the numerators according to this operation, which in this case is addition. So that's 6 plus x plus 2. And so finishing that up, we're just going to combine like terms on the top, and that's going to be x plus 8. And we're all done with that one. Yay. If you can't tell, I'm very tired. All right, next one. Same thing. Notice first that we have identical denominators. And so we're just going to, that rustling is my child playing with Legos. I'm sorry. So we have the same denominator. So we just move that here and then combine the numerators according to the operation, which is addition. So x squared plus 3x minus 2 plus 4x plus 12. And again, at this point, all there is left to do in this step is we're going to combine all of our like terms. And so that's going to be x squared plus 7x
That's what
plus
we've
10.
been learning about today. We've been learning about alligators and cactuses last week, and birds today, and lions today, and giraffes today, and alligators today.
That's wonderful.
And even parrots. Actually, we won't. Actually, you did.
Okay. Can I finish my video? You want to watch your tablet for a second?
No.
Okay, well, I need you to go sit quietly somewhere else, please. Just for a second. All right, so at this step, I've combined or I've added the fractions into a single fraction. But I want to see if this will simplify like what we did on Friday and Thursday. So I'm going to factor the top. That's actually going to factor into x plus 5, x plus 2. And so then we'll be able to simplify some things in the numerator and denominator. And so these two will simplify. And then we'll just be left with x plus 2 divided by x minus 2. So we're done with that one. And we know that because there's nothing left to factor. There are no common factors. There's nothing that will cancel or simplify. All right. So let's go on down to this example where we're again going to notice that we have a common denominator already. So we're just going to write that here. And then we're going to combine the numerators according to the operation. And in this case, this is subtraction, so we'll distribute the negative throughout the numerator. We don't do that to the denominator, just in the numerator. So we'll say, okay, negative 2x plus 1 plus 3x plus 1. And then let's clean that up a bit. So we'll have 3x minus 2x. That's going to be x plus 2. And then we're going to factor this difference of squares on the bottom. And hopefully you see that we're going to be able to cancel these two terms. We're just going to be left with the 1 up here. So we'll have 1 over x minus 2. And that's all. Okay. So now I want to go on to some where the denominator is different. And notice the 5 and y are obviously different and they have no common factors. And so we want to rewrite each fraction with a common denominator. And that common denominator is going to be 5 times y. Because really what you're looking for is the least common multiple of both denominators. And the way you check is you're like, hey, 5y is what I'm thinking my common denominator is going to be. Well, does this denominator that is common contain a factor of 5? And the answer is yes. Does it contain a factor of y? And the answer is yes. So I'm ready to go. But the only issue is I have to change this fraction into this one. And the way I do that is it's really magic, right? So you're going to look at it and you're going to be like, hey, this is just a 5. I need it to have a y, so I'm just gonna just totally put it there. I'm just gonna do it. But here's the cool thing. The thing that makes this work is that if you do it to the bottom, you have to do it to the top. And so I've just multiplied the top and the bottom by y. And now I have 5y, which is exactly what I want. And so then moving to the second fraction, I'm missing a 5 here to make it look like this common denominator. So I'm just gonna put it there. But if I do it on the bottom, I have to do it on the top. And then let's clean this up into this step. So this fraction, 5 times y on the bottom, y times 1 on the top, is actually just y on top, y times 1. And then here we'll have 1 times 5, and that'll just be 5. So now that we have our common denominator, we're going to just do what we were doing before. We're just going to combine the numerators and divide by the common denominator. And there's nothing that simplifies or factors or anything like that here, so we're done. All right, so let's do the same thing again. So let's determine our common denominator for this expression. Let's go ahead and clean this up a bit and make it distribute the negative. So that's plus this. And so the common denominator here, these have no common factors. So I'm just going to have to take both as my least common multiple or my common.
Do we have a color marker?
Do we have a color marker?
A color. That is a color.
I have a red pen. I have a blue pen. Would you like these? And I have this lovely orange pen. Would you like to play with those? Okay. Cool. All right, so again, we need to transform these differing denominator fractions into these that have the common denominator. And so we're going to ask ourselves, okay, this one is missing what from the common denominator? Well, it's missing an x plus 3. So I'm going to multiply it there. Now I have the common denominator that I need. I multiplied on top and bottom, so I haven't violated any of the rules of algebra. This one is just missing an x. So I'm going to multiply on top and bottom. And so now let's rewrite it. The denominators are both the same. So let's just figure out these numerators. This is 5 times x plus 3. And then this would just be negative 7xy. Okay, so now that our denominators are the same, we're going to combine the numerators according to this operation, which is just addition. So this will be 5 times x plus 3 minus 7xy. And I'm pretty sure that top is not going to factor, but I do want to like bust all this apart and distribute it through so I can actually see that. So that's 5x plus 15 minus 17xy over x times x plus 3. And so, I mean, it's pretty obvious at this point to me that I can't factor this because this is just crazy looking up here. There's nothing I can do with that. And so we're done with this one. And so that's it. That's it. That's just terrifying, right? Like, my God. All right, let's do one more of this type, and then we'll do a couple of the final type that have some overlap. So common denominator, let's handle this. Let's distribute the negatives. So we're all addition. Addition is nice. Okay, so these have no factors in common. So their least common multiple is just going to be both of them, right? We love this because it's very simple. We just take them both. And then we figure out what we're missing and deal with that. So over here, I don't have an x minus 3. I do it to top and bottom. Over here, I don't have an x plus 5. So I just add it because algebra is amazing. Okay. So at this point, the denominators are the same like over here. So I'm just going to handle the numerators here. So that's x times x minus 3 and negative 2 times x plus 5. And so now we'll do that trick where we combine everything over that common denominator and write it as a single fraction. This is x times x minus 3 minus 2x plus 5. Again, I can't cancel anything right here because of this. This is locking everything up there. And so I'm going to distribute through this multiplication and see if I can combine some things and maybe factor it. Let's see. So this will be x squared minus 3x. This will be minus 2x and then plus 10 all over x plus 5, x minus 3. And at this point, it looks like a trinomial, right? Maybe I can factor it. Let me finish combining some terms to see. At some point, maybe you could. This one you can't. because there are no two numbers that multiply to positive 10 that add to negative 5. So can't simplify, can't cancel anything. So we're just going to call this day 2. Okay. Can you get some regular paper, please? Can we do that? Look, it's right here under my desk. Under the desk right here. Would you grab some regular paper? Thank you. You can draw all over that. All right, last 2. So now we're going to move into some of these that have some overlap or common factors in the denominator. So let's handle this subtraction first. Get that out of the way so we don't mess it up. All right. So the common factor here is actually going to be 7x squared. And let's look at why. The coefficient, you got to have a 7 over here. It's got to, because it's in one of these. And then I have to have at least x squared because that's the largest power of x here. So let me ask myself the question, in my common denominator, do I have this first one as a factor? Sure do. There it is. And in the second denominator, do I have that as a factor of the common denominator also? Well, is 7x a factor of the common thing here? Yeah, absolutely. So that's my common denominator. And now I just need to add the things that are missing. Well, here I just need to multiply by 7. And here I'm just missing 1x. So I'm going to do that. And then let's clean this up. So 7 times 2 is 14. Negative 3 times x is negative 3x. And then we can combine the entire thing into a single fraction. So that's 14 minus 3x. And that's not going to simplify any either. So we're done with that one as well. And then the last one that's a little bit different. When you're trying to find a common denominator, you always want to make sure if the denominators are different and they can be factored, you want to do that so that it makes it a little more obvious, what you're dealing with. So we'll go ahead and handle that. And so I'm not going to do anything as far as combining. I just want to factor the bottom. So we're going to factor out an x minus 5. Going to factor out a 5, x minus 5. So now it's a little easier to see what the factors of each denominator are so that I can make sure I find a common one. So let's see. Let's see. I got an x plus 5 that's got to happen. One of these has an x and the other one has a 5. So I know that those both have to exist in the common. Okay. Oh, thanks, baby. All right. So, wow. Thank you. That's okay. That's my stapler falling on the floor. All right. So let's go back and add what we're missing to transform these fractions into having a we're not doing that right now. I need you to go sit down, please. You may have one of those after I'm finished. Okay, after I finish, I have one more problem to finish. I need you to go sit down. All right. So let's look at our common denominator and what's missing. Well, here I'm just missing a 5. So let's handle that. Here I'm just missing an x. So let's handle that as well. So now my denominators all have a 5. They all have an x, and they all have an x minus 5. And so that's what we've got here. 5 minus 5 is 25. Negative x times x is simply negative x squared. And so at this step, we can actually go ahead and combine this into a single fraction because we have that common denominator. And so let's do that. So common denominator 5x, x minus 5, 25 minus x squared. So this is a difference of squares on top here, right? We need to factor that to see if anything is going to simplify. And I don't really like it being reversed like this. So I'm going to factor out a negative 1 first and do that trick where it's going to turn this around. So it looks like a proper, the difference of squares we're used to. And so now that I've factored out the negative 1, I'll factor difference of squares, x minus 5, x plus 5, rewrite my common denominator, and now let's check to see if anything will in fact cancel. Of course it will. Those two will simplify away. And now I'm simply left with negative x plus 5 over 5x. And there's nothing else common that we'll factor out here. So we again consider ourselves completely finished. All right, so those are the examples. Your assignment is posted in Classroom, and that is due tomorrow. Also, homework from simplifying rationals and multiplying dividing rationals from last Thursday and Friday. The keys are posted here. And so those assignments have been returned, and I encourage you to go check your answers and prepare some questions if you have any for tomorrow. All right, I hope that helps.